Hello students, my name is Sumit Mehta. So in today's lecture we will discuss about a different lot many cases of the equation of the line depending on the conditions given. Okay, so first we will talk about the first point we will talk about is equation of a line through a point through a given point, okay, and parallel to given vector. Okay, so let's say we are given a line. So this is your x. Let's say this is x, this is y, and this is z. Okay. So what we need to do is let a be the position vector of the given point. Let's say this is vector a with respect to the origin, and let L be the line passing through the point A and is parallel to vector B. So let's say there is vector B and the line is passing through a point on the line A and is parallel to vector B. So this is your line L. So I can say that, let's say this is point P on this line. So this AP vector is given by, and this is your R. So AP is given by OP minus OA, where this is R minus A, and AP is parallel to B, so I can write it down as lambda times B, because that we have studied in straight lines. So I can write down this as A plus lambda times B vector. So this is the equation of the line passing through point A and parallel to another vector B. Okay, so this is the line. Okay, and now the derivation of Cartesian form from vector form. So now we will study about Cartesian form. So this was the vector form. Now we will study about the Cartesian form of this line. Okay. So let's say R vector is given as and A vector is given as x1 I cap plus y1 j cap and z1 k cap, and B vector is given as ai plus bj plus ck. Okay, so substitute in the values in equation 1 in this equation, and what we will get is the parametric equation of the line, which is given by x minus x1 over a is equals to y minus y1 over b is equals to z minus z1 over c. Means the resultant x minus the point initial point x upon a. So this is x minus x dash upon a is equals to y minus y1 upon b and is equals to z minus z1 upon c. Okay, and these a, b, c are, let's say, the direction ratios of the line, or you can replace this by the direction cosine also. Okay, so this is the equation of the line passing through a point and parallel to given vector b in Cartesian form. Now let's discuss about equation of line passing through two given points. So students, now let's say these 2 points are given by x1, y1 and z1. A point A and point B is given by x2, y2 and z2. Now we need to write the equation of the line passing through these points. Okay, so in the vector form this will be given by A vector plus lambda times B minus A vector. Okay, means the parallel to B minus A and passing through this point. Okay, and in the Cartesian form, so this is vector form, and in Cartesian this is simply x minus x1 over x2 minus x1 is equals to y minus y1 over y2 minus y1. So this is somewhat similar to the point that we have discussed earlier, z minus z1 over z2 minus z1. Okay, so this is the equation of the line passing through two given points. Now we will discuss about the angle between two lines. Okay, so students, now we will discuss about how to find the angle between two lines. So let's say these two lines L1 and L2 are given. This is L2, this is your L1, and we need to find the angle theta. Okay, so let's say L1 having direction ratios A1, B1 and C1, and L2 having direction ratios as A2, B2 and C2. Okay, so as we know, therefore the angle theta between them will be given by cos theta is equals to A1 A2 plus B1 B2 plus C1 C2 mod whole over root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square whole mod. So this is the angle between two lines. Okay, in case the line L1 and L2 do not pass through the origin, we may take L1 dash and L2 dash, which are parallel to L1 dash and L2 dash. So this is just a special case of the case that we have discussed here. Okay, so now next we will discuss about the shortest distance between the two lines. Okay, in that we will discuss two or three cases, means or between the two skew lines and between two parallel lines. Okay, so students, now we will discuss about the shortest distance between the two lines. Okay, so the first is when the distance between two skew lines. Skew lines mean that they are at some angle between. Let's say one line is this, one line is this. So these lines will meet at some point. Okay, so this is ST and this is, let's say this is a perpendicular P and Q. This is line L2 and this is L1. Okay, so let L1 and L2 be two skew lines and they are parallel to B1 and B2. Okay, so if PQ is the shortest distance between the two lines, then it is being perpendicular to both B1 and B2. So let me write position equation of the both the lines, and another line is A2 plus lambda times B2. I have written here the equation of the two lines in case they are passing through a point and parallel to some vector. Okay, and so the position vector, or to find out the shortest distance between these two lines, the formula for it is very simpler. B1 cross B2 dot A2 minus A1 or B1 cross B2 mod. Okay, so this is the distance between the two lines in vector form, and in Cartesian I will write this as x2 minus x1, y2 minus y1, and z2 minus z1, a1 a2, b1 b2, and c1 c2 mod or b1 c2 minus b2 c1 whole square plus, you can remember this like b1 c2 minus b2 c1 square plus c1 a2 minus a1 c2, c1 a2 minus a1 c2 whole square, and what left is a1 b2 minus a2 b1 whole square. Okay, so this is the formula in Cartesian form. And similarly, in case of the distance between the two parallel lines, the b will become b1 and b2 will becomes equal. So I can replace this b1 and b2 by only a b. So this will becomes only b vector. So all will remain same, and the formula, this will be a special case for this formula. So I hope students now you are pretty clear about the different types or the different equations of the line, and in the next lecture we will discuss a lot many questions based on this. So stay tuned for that lecture. Thank you students. Happy learning. Stay blessed.